Okay, let's do a little bit of math with the Marchant Type 1 because it does have a little bit of a unique functionality. So even though it was created probably around anywhere between 68 and 71, I'm not sure exactly the year, it actually has a memory component to it. So if I'm typing in numbers and I hit plus, it will keep on building up in its memory each number that I hit plus on. So I did 12 plus 14, that's 26. Let's just do 4. And I hit the total button and it gives me 30. So it keeps a running total in its circuitry. So I can do the same thing, 12, let's do 6 minus 3 plus, so 12 minus 6 is 6 plus 3 should be 9. So it just keeps running that total, and you can hit the plus or minus key almost at any time throughout your mathematical operations, so that it will add up the numbers that you're looking at. So that's one interesting aspect. The second thing is the way that it multiplies and divides. So let's do multiplication first. So and I've actually written out a little problem for the multiplication and the division, which I guess you can't really see that, but let's ignore that for now. All right, so if we say 12 times 2 equals, answer's 24. Now if I type in another number, so let's say 3, the calculator still remembers that the first number was 12. And so if I hit equals, it's gonna now do 12 times 3, which is 36. And if I do 4, it still remembers that the first number is 12, so 12 times 4 is 48. Division does kind of the same thing. If I do 12 divided by 2 is 6. Now it remembers what the dividing number was, so it's going to remember that too. So if I say 10 equals, it gives me 5. And if I 8 equals, it gives me 4. So it continues to remember the 2. So how does that help you? So let's do a practical example. This I think is kind of interesting. So the calculator was really designed for for doing business or surveying or things like that, where you would potentially need to apply the same percentage rate to a group of numbers, or do finding percentages and things like that. So you'd need that same multiplier or that same divider over and over again. So it actually makes kind of sense whenever you think about it like that. But let's get this over just a little bit and we'll zoom in. Let's see if I can get all this together. Okay, I don't know if you can see that very well, but we'll go ahead and try this. So I've got a listing of sales numbers. So the first thing is, let's go ahead and figure out what our total is. So I'm going to clear this, say 35 plus 20 plus 65 plus 40 gives me my total. And I don't think that total's right. 35 plus 20 plus 65 plus 40 plus equals 160. Okay, so that's right. So 160. Now let's say there's a 15% discount. So 1 plus 0.15 minus. So I need 85% of whatever that sales number is to get the discounted price. So I'm gonna take that 85%, leave it in there, and multiply it by the first sales price, so by 35 equals, so 29.75. Now in the end, I'm going to want to do a total, so I'm going to go ahead and hit plus now. So now that's in the memory. So let's do the second product. I'll just hit 20. Now it remembers to multiply it by 85%. So 20 times 85% equals 17. And I'll hit plus. So now that's added to the memory. Same process, 65 times the 85%. So 55.25. Add that to the memory. And then 40. Okay, so that gives me my discounted prices. Add that to the memory. Now since I added all of them, I'm just going to hit total, and that gives me my discounted total, 136. Okay, so pretty easy, I think. Now, let's take it a step further, and let's say I want to know the percentage of each product of the total. So we'll do the same thing. I'm going to take 29.75 divided by the total, 136, equals 21.88%. I'm going to go ahead and do a check total as I go. So I'm going to hit plus, get that into the memory. Now I'll do the next one. So the 17 divided by 136. So I type in the 17, enter, because it remembers the 136. So that gives me 12.5%. I'll add that. And then 55.25, and it remembers the 136. Gives me 40.63%. Add it. And then the last one, 34 equals, so 25%. Now I've added them all up as I went, and so if I did all my math right, that should be close to 100%, and it's exactly 100%. So, fun little example of how it works.